All right, so now that we know how to write the end behavior, now we're going to put all the pieces of the puzzle together and figure out what's happening with each polynomial based on the degree and based on the leading coefficient. So a reminder that the ends of our polynomial graphs are going to be determined by the odd degree. So if it's an odd degree, they're going to point in opposite directions. And if it's the same degree, they're pointing in the same direction. Now we're adding one more piece, and we're going to talk about this leading coefficient. So if we have a leading coefficient where the value is greater than 0 or positive, I want you to put this in your brain. Your end of your end behavior is going to end up. So let's put that together with an odd degree. So here's an example of a leading coefficient that's positive and an odd degree. Well, if we're looking at this graph, 1, we know that it ends up because of this leading coefficient, and we put that together with, hey, odd degree is opposite direction. So since this ends up, I have to start down. So again, those are going to be how we're going to determine where our graph is going based on the end behavior. So then we can write it as limits. We say as x approaches positive infinity, at p of x approaches positive infinity, and then as x approaches negative infinity, p of x is approaching negative infinity as well. Okay, so now we're going to do positive leading coefficient and an even degree. Well, again, my function is going to end up, and because they also have to go in the same direction, I'm also going to point this end up. Now that we have a sketch of our graph, we can say, hey, as x approaches positive infinity, my graph is going to positive infinity, and as x approaches negative infinity, my graph is also going to positive infinity. Okay, now we're going to change gears. When our leading coefficient is negative, I want you to put this in your brain, it ends down. So notice these guys are ending up. These guys, when the coefficient is negative, they're going to end down. So putting that together, it's ending down. With my odd degree, I know they have to be in opposite directions. Here's my graph. So I'm ending down. They have to be in opposite directions, so this one's pointing up. Now we can talk about our end behavior. As x approaches infinity, f of x is approaching negative infinity. So here's that guy there. F of x, p of x. Sorry, I'm so used to saying f of x. P of x. And as x approaches negative infinity, p of x is approaching positive infinity. So that's how we're going to write that. And then very last one, again, when I have a negative coefficient, I'm going to end down. And because they have to point in the same direction, this guy is also going down. So writing our end behavior, as x approaches positive infinity, p of x approaches negative infinity, and as x approaches negative infinity, p of x approaches negative infinity as well. So there's your overview, putting it all together. Let's try one quick example. We're going to identify the leading coefficient and degree, and that's going to help us write the end behavior. So here we go. First, we need to think about, is it in standard form? This guy is. Then we can identify the leading coefficient. Here, the leading coefficient is -1, so that tells me I'm going to end down. So I know that I'm ending down, so we're going to do a little visual sketch. Then I have to look at the degree. My degree is a 4th degree. That is even, so I know that it has to go in the same direction. So since I'm ending down, my other one is also going to end down. So now I have kind of a visual sketch, and I can write my end behavior. So as x approaches positive infinity, f of x, or in this case, q of x, also approaches negative infinity. That's that ending down. And then the limit of q of x as x approaches negative infinity is also going to be negative infinity. When you have even degrees, remember these guys have to be the same. So that's a good check. If you had odd degrees, one would need to be positive and one would need to be negative. So there is all the pieces to your puzzle. If you guys have questions, come find me. If not, I'll see y'all in the next one.